delivery hero, and he's going to be shedding light on positional biases and some strategies for the mitigation. Of course, the abstract that he provided was super intuitive and thought-provoking. So I look forward to this talk from him. Let's welcome Burak once again with a big round of applause.
Hey everyone, thank you all. Today I'm gonna talk about positional bias. My name is Burak, and let me introduce myself. So I'm actually a PhD candidate in computer science, and I've been working for 16 years in various fields. I work with banking company, telecommunication company, and right now I'm working as a staff ML engineer in Delivery Hero in search ranking team. So who are we? We are food ordering and delivery company. We are serving 70 plus countries and 2.2 billion people. And we actually have partnered 1.5 million restaurants around the world. And we also have serving restaurants and Q-commerce side. So you can see the different brands for Delivery Hero. Maybe you heard some of them: Foodpanda, Glovo, Pizza, Yemek Sepeti, and Talabat also. So these are the brands under the Delivery Hero brand, and we are actually serving all of the search for these brands. So first of all, why positional bias? Why is it important? In order for us to answer this question, you need to ask yourself, when was the last time you scrolled the second page, or you scrolled at the end of the page actually? And if you are hungry at that time, what would happen actually? So did you actually wait for all the search result, or did you just give up after the third or the second position? So that's why it's important actually, because there are a lot of alternatives, and therefore we need to actually find it in the top position for the search result what we are looking for. So this is actually proven. So in the Google search, it's proven that the user clicks 10 times more than the 10th position in this research actually. So this is also affecting the presentation bias as well. And this is also affecting our customers as well, because to make fair results for all of the vendors we have, we need to actually adjust the result. And to make fair result for the users, we also need to show them to actual results which they are looking for. For instance, on the right side, there's a screenshot taken from the Foodpanda app, and this search result from the Italian query. So as you can see, there are only 3 restaurants coming up in the first page actually. So how long can you go far? It depends on you, of course. The reason is you can actually trust the algorithm, say that you are actually looking for some restaurant, but it doesn't exist over there in the top result, or the result actually are truly relevant result on the top, so that you are always trusting the relevant results coming up in the top position, or you are actually training a model in a bias historical data so that it's actually affecting the result somehow, which is coming from the interaction results, right? Clicks or orders. So before jumping to how, I like to actually explain an interesting problem, which is German tank problem. Who is familiar with this problem? Please raise your hands. 1, 2, 3. Okay. So during the Second World War, Allies actually wanted to estimate the number of tanks produced by Germans. So they actually hired statisticians to accurately estimate this. So they've come up with a formula for this one, and Germans are actually particularly using their serial number in the tanks. And when they capture the tanks, all of the serial numbers are there actually. So let's say serial numbers are here 19, 40, 42, and 60, the total number of tanks is in this formula equals to 74. So they come up with this formula, and they actually use the formula to estimate it. So this is the actual result taken from the history. So in the 1940 June, statistical estimate was 169, but intelligent estimate was 1,000. And again, 1 year ago, 1 year later, 2044, but in the intelligence estimate, it's actually 1,550, and it goes a lot. So when we look at the German records, which one is the true one or which one is the closest one? Actually, it was the statistical estimate was the closest one. And as you can see in the numbers in the table, they are very close, and the intelligence estimate was far away. So, but why does it matter to us? Because it's actually similar to our problem. When we have no impression data, when we don't know how users go, how far they go, we actually need to estimate somehow this information. So we don't know how far user goes, right? Maybe in the third position, maybe in the 10th position. So that's why this is important for us. So, and how is actually, again, for instance, when you are using web, you have a bigger screen, which means in the first page, in the first screen page, you have 8 results, but in the app, you have only 3 results coming from the search results. So again, let's look at the numbers again. When we look at the click count per position, almost 50% of clicks are coming from the first position. And this is actually going down for second and third position. And after that, it's almost insignificant. For the order, it's almost 60% of order coming from the first position. So that's why the positional bias is so important for us as well. Because if you don't see the vendor, you cannot be ordered from the this vendor actually. So how this architecture is working right now for us? So currently we have Elasticsearch for candidate retrieval. So we are actually, when the query is given, we are retrieving the vendors, and then we are actually giving it to the ranking ML model. Ranking ML model is sorting the result based on a relevance. So what are we using as a feature? So we are using textual similarities, behavioral and interaction features, and also price and context. But the positional bias is actually coming from behavior features or interaction features, aka click count or order count. For relevance, we are using actually binary relevance. So either this restaurant get order or not. So this is like purchase or not. For offline evaluation, we use actually NDCG as a metric. So we are using 2 different metrics for NDCG, NDCG at 50 and NDCG at 2 to 10 position actually. Why do we use actually 2 different metrics for NDCG? Because as you can see, most of the order are already coming from the first position. So in majority, if it's coming from there, in overall, the effect is actually less if you improve your system for the other positions. So therefore, if we actually improve between the second position to 10th position, even we improve the model, the overall result would be insignificant. So in order for us to prevent that, we will be using 2 different metrics, NDCG at 50 to NDCG at 2 to 10. So again, remember the almost 60% of order coming from the first position for us. And on the right side, this is the NDCG graph changing based by the position. As you can see again, it's actually exponentially decreasing. But NDCG isn't enough itself. We also need to look at the diversity of vendors as well. So how many listing vendors have been shown in the top K position, top 10, top 20. Or we also need to look at the novelty, how well restaurants are shown in the top K result, right? So that we understand that the diversity and novelty is also obeying us. So let's look at the methods. So first method is actually positional aware learning. So this method is actually, we are using position as a feature. So on the right side, you're actually seeing that we have some items in the training set and we have some features. And in addition to these features, we are actually adding position as a feature, like here, 1, 2, 3, 4. But during the prediction, instead of using the actual position, we are using some constant value, some fixed position. For instance, 0, 1, 5, or 50. But when we actually conduct this experiment, it directly leads to overfitting. So when we use this positional, since the majority of the position are coming from the first, models are learning to like give it to all the information to the position. So in order for us to prevent that, we need to actually unlearn the model somehow, like prevent learning all of the information from the position. So I come up with an idea to use dropout. So dropout usually used in neural networks to prevent overfitting. And so we are actually disabling some of the neurons while the training going on, and so that all of the neurons can learn from all of the information. But in this case, since we don't have any neural networks for that, we are using discarding the position for some sessions. So for instance, 10% of the sessions, I'm actually not using the position for the information, I'm discarding it. Here, as you can see on the right side of the table, we have 5 different sessions, some features. 4 of them, actually, we are using the positions, but 1 isn't included. So we are discarding that. So this actually worked. And in the NDCG, this is the different value for the fixed position and dropout ratio. And this is one of the best table, by the way. We have tried different values for dropout for fixed position as well, but it didn't work. So I actually added just 2 examples for that. And as you can see, if the value was 0 and the dropout was 0.1, the overall NDCG isn't so affected, but we have some uplift in the NDCG at 2 to 10. And when we actually look at diversity is also increased almost 5% compared to existing model. So the next method is, we will compare all of the models at the end, but let's look at the other methods actually. So another method is using the proximity features. So we already have some features I already described, like texture features or behavior features. But in addition to these features, we can add the proximity feature, which is maximum, minimum, or average position for the past K days for orders, clicks, or all together, so that model can understand this vendor got order from where for the past days. So this is the best possible feature set. We tried different set of combination. So this is the best possible feature set. Order average position for the last 30 days, click average position for the past 30 days again, and all average position and maximum position for the order. And for the NDCG part, for overall, it's not affected, but for the 2 to 10, it's actually, we have uplift almost 8%. For diversity, unfortunately, we don't have a diverse result for that. Even the NDCG is improved. Since we didn't have any diversity uplift, So we actually decided not to use that in any case. The another method is punish interaction features actually. So during the click count calculation, we used to use like just one click count for any position that matters. But if the position does matter, we need to take into account that, so that we actually found the formula for that to punish if the position is higher, but if the position is lower, let's say 10 or 20 or 50, then it should weight higher. So this is also similar to inverse propensity weighting. So when we are actually comparing to the click conversion, we are actually first we set up a weight for that using the number of orders per position, and then we actually calculated the click count. So instead of just adding 1 and 1, we take into account to the position as well. So for the NDCG result, again, compared to the current model, we have 8% uplift for the NDCG at 2 to 10, but overall result isn't affected again, but this is expected actually. And diversity is also increased almost 3%. This is what we wanted. So the another approach is coming from the research actually. So there is a paper called Unbiased Lambda Mart. So in this case, while we are learning the model, we are also learning to estimate the unbiasing as well in the model side. So we don't need to add or change anything in the feature side, but we are changing the loss and the model side. So in the regular Lambda Mart, we are actually trying to find out the difference between the position. Like we are trying to compute the gain. If we change this range, how is going to happen? So for instance, in this graph on the regular Lambda Mart, if you change it, you can see the Lambda values for the misranking efforts for the NDCG part. But in this case, in the research, we are calculating lambda, but we are also calculating bias impact from the formula they given, so that we can actually take into account to unbias the model as well. So again, to compare the current lambda mart to positional bias lambda mart, so we are using NDCG. So the objective is lambda rank, sorry, and the method is lambda mart. So, and you can see the class in the Microsoft repository here. For unbiased lambda mart, we need to use custom objective, and we need to use 2 additional parameters for that. First, positional means. The second one is punishment ratio, and the method is lambda mart. So these parameters are actually using to find out the how biased our data or how biased our model is. But this paper is actually a bit complicated to implement, and they also release their own implementation, but they actually changed the source code of the LightGBM, and it was the older version of the LightGBM. So instead of using that, Zalando actually released another paper called a general framework for pairwise unbiased learning terrain. So they actually simplified the formula for that. So in the method, you can see in the second, this is the original version of the formula, but in the third one, it's the simplified version one. So since it's the simpler solution, we decided to use that version. Of course, in any case, we need to implement the custom objective. So LightGBM, we are using actually LightGBM in our site. So LightGBM also supports the custom objective as well. So we use custom objective to overcome this. And since our data is big and we need to parallelize somehow and to overcome GL. We use SciPython, Python with C data types for this matter. And this is on the right side, you can actually see the code snippet of the C code actually. And we use C programming language and usual makefile, and we just build it and use that. So again, for using the unbiased lambda mart, we can jointly estimate the bias, and we can actually learn an unbiased rank here while we are doing that. So by doing that, we need to actually return two different things for the function like GBM offering. First one is the value of the first order of derivative, which is gradient. The second one is second order of the derivative of the loss, which is Hessian. So we need to return those values from the custom objective function and give it to the like GBM. And you can also see the original implementation in the Microsoft side. There are 3 different functions for that, and these are actually the same as we used. Just only we use the unbiased formula. And in the inference side, we don't need to change anything actually, because since this is only during the training, we don't need to change the inference side anything at all. We just need to implement in the training side. But good news is XJBoost actually planning to support this function. So they already released the release candidate version in the second version. So there's an experimental feature called unbiased lambda mart. You can actually try and use that as well. So these are the different punishment ratio for us. P-values 0, 1 second, and the position power is actually fixed 0.5. And when we use these values, actually, we end up like 7% uplift in the NDCG 2 to 10, but overall actually isn't changed again. And diversity is almost also increased almost 3%. So overall, if we use positional aware learning, we have more diversity, and we have actually NDCG gain in the NDCG at 2 to 10. Overall, we might actually lose a bit, but this is not significant. We can actually use that. But if we use proximity, we don't have any diversity, and even we have NDCG gain, since we don't have diversity, actually we cannot prevent the position bias for that. For punish interaction, again, we have diversity and we have gain in the NDCG, but again, we need to change the calculation of the interaction, which means we need to rely on the past model interaction. So if we change our model somehow in the future, it doesn't work because the position is actually coming from the old version. But if we use unbiased lambda mart, since it's during the training and we don't change anything in the feature interaction, we have both diversity and NDCG gain to the end. So in the conclusion, if you are using click on purchases as an in-place label, their position also matters and you should take into account. We can use a custom function to unbias our model as well. And when I actually done the research, a lot of researchers are done on the neural ranking side, but a few on the gradient boosting decision tree side. So if you are planning to have some, you can actually choose one. So that's it from my side. If you have any questions or feedbacks, I can take it.
Okay, so we already have a question. Thank you for the great talk once again. So we already have a first question in the room.
Yeah, thank you for a very interesting talks and your insights. I wonder whether this assumption that the position bias is a monotonic function of the position should be put under question more forcefully. So if you look at NDCG, we apply a discount as monotonic function of the rank. But if you look at unbiased lambda mart, when we learn the bias, it might not be a monotonic function of the rank. And maybe if we use NDCG in simpler techniques, maybe we should also look at this function. And I wonder how much you saw this in your experiments, and also with what you saw online, how much this assumption should be put under question depending on the layout of the pages and so on.
So currently we haven't done any online experiment. We are waiting for it actually, but so in order for us to put in, like take into account this one, we need to change the law somehow to understand the biasing. And this is not something actually easy to find out, because the bias is also coming from other things as well. For instance, relevance. So if the search results actually are relevant, then we should actually put in the first position for this result as well. So that's why we actually focus on this matter.
Okay, so we had one question online, but apparently, as you answered in the answer here, that none of your experiments were online. So I'm not sure if it still makes sense to ask the question, but we still have more questions in the room.
Okay.
What kind of a signal you used for NDCG calculations?
And again, for relevance, you mean?
Yeah, clicks, purchases for NDCG.
Only purchases we are using, and this is binary.
Thank you for the talk. The metrics you showed were based on 30 days period. How do you think this works with seasonal data? Doesn't this bias towards short-term patterns at the expense of the longer-term one?
So we haven't done anything on the seasonal part, but I think since this is actually coming from the restaurant side, the seasonal effect should be similar compared to overall, because maybe Ramadan is happening, for instance, yes, but apart from that, there is not much affecting the overall result for that matter.
Because the underlying preferences are pretty static. This is what you mean.
Yes.
Makes sense. Thank you.
Hi. Since this business is regional, so what is the relevance of the whole population, 2.2 million customer and 70 whatever restaurants, 70 countries and stuff like that? The data set is much smaller, isn't that?
No, it's not smaller actually. We are using 1 month data to train our models, for instance, and we are using all of the countries, by the way. We are not separating. And since we are serving all of the brands, it can be any brand actually coming from the data set. And yes, I mean, we are serving 7+ countries. So yes.
Yeah, but the restaurant catalog is regional. It's
yes.
City-based also. So then
yeah,
the data set is much smaller, isn't it?
No, we have all the restaurant information in our catalog.
Okay.
Hi. First of all, thank you for your talk. I had a question about for the positional bias. You did your research on a list view presentation. Did you also run some tests on, for example, a different layout like a grid? And if you did, are you using different models to show the results for a list view or for a grid view? Because I think the position is really different for a grid view, because if you have a grid which is like linear from left to right, from top to bottom, maybe position 3 is better than actually position 2 on the right. And how did you handle that?
We haven't done that yet, actually. Yeah, we discussed that actually, because as you mentioned, if it's grid, then all the 4 different results actually can be considered as a first position, or maybe horizontal way, it's also the same. But yeah, we haven't taken into account for this matter, but we are planning to do that in the future.
Okay, thank you.
Do we have any more questions in the room? Oh, we have one.
So positional bias is understandable, but what about geolocation bias? If you're hungry, you should wait for less time. So maybe the first position, the closest one, is most important.
So that's actually a different thing. So we are using distance actually, one of the feature, let's say, but how does it actually affect the actual result for this one? So of course, this is affecting the result when we use it as a feature, but you are expecting a shorter distance instead of longer distance, right? Like this is common expectation. So if we change that, we actually getting worse to the result, I believe. So how can we know that?
Yeah, so if you position by relevance, so you don't want to boost some brands, for example, and have more diversity, but the user can be in different geolocations. So, and they can search the same brand, for example.
Okay, got it. So we haven't considered that yet.
Thank you.
Okay, looks like we do have questions.
Thank you so much for the presentation. So I had a question regarding the dropout. So you explained that you are basically dropping out by 10 or 20 or 30%. And are you dropping out randomly doing it, or
Randomly?
Or you are like, okay, it's random. So then if we actually have a systematic sort of a sampling there, then should we not actually improve the entire positional awareness learning?
Not exactly, because we have big enough data set for that. So even you can actually sample based on some assumption, it would lead the same result actually.
Okay.
Okay, thank you once again, Burak, for such an insightful session. So
Thank you.
let's give him another round of applause for a great talk.